Hello, it's Dumplet here. Welcome to a collaboration project between Dumplet and Cedie's Mathverse. You guys can watch the other videos related to Hong Kong International Math Olympiad problems by visiting Cedie's Mathverse YouTube channel in the link in the description. Let's start. Find the sum of all primes p such that p squared plus 50 is prime. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, I put in here in the title instincts because there's probably one thing that a lot of contestants did during the contest, and that is to try out some prime numbers p. For example, they might try like 2, 3, 5, 7, 11, 13, and 17, and let's just see like what's going to happen if I substitute them. So if I let p to be 2, 3, 5, 7, 11, 13, or 17, then the respective value of p squared plus 50, p equals 2 gives 54, 3 gives 59, 5 gives 75, 7 gives 99. Well, you can see here, 11 gives 171, 13 gives 219, and 17 gives 339. Well, I've only listed down 7 prime numbers and its respective p squared plus 50 counterparts, and I only have one prime number here, that is when p equals 3. Now, usually, if we go down the line, you can try to do something with it, but you don't have enough time because there's only a limited amount of time in the contest. But you can see here that if you're going to trust your instincts, you can try to at least assume that maybe p equals 3 is the only one. And if that's your instinct, then you're right, you have very good instincts. But let's try to analyze this first and take a look at the other numbers that are not prime. Now let's discuss on the reasons why it's not prime. Like 54, it's not prime because, factor 6 times 9, 18 times 3, and so on. Well, the 75, same thing for that. 99, 171, 290, and 339. But all of them have one thing in common, and that's that all of them are divisible by 3. Like, for example, 54 divided by 3, that gives 18. 75 divided by 3, it gives 25. I'll just write down here the other values when divided by 3, and you guys can see for yourselves. And what we can get here is that there might be something related to the number 3, and in fact there is. And if you want to prove that p here must be 3, well, let's try to make the assumption first that, let's say, p is not congruent to 0, 1, 3, or in simple terms, p is not a multiple of 3. Then by Fermat's little theorem, we know that p raised to 3 minus 1, which is just p squared, that's going to be 1 modulo 3. Now we can conclude this because the exponent of p here is 2, and p is not divisible by 3, and we know that p is a prime number, so the GCD of p and 3 is just 1, so Fermat's little theorem is going to work. And, well, following from this thought, p squared is congruent to 1 modulo 3. This would mean that p squared plus 50, 1 plus 50, that's going to be 51 modulo 3, but 51 is just 0 under modulo 3. So we can conclude that, okay, if p is 3, then it's prime. But if p is not 3, then the resulting expression p squared plus 50 is divisible by 3. And that's the case we see here. And if p is not equal to 3, then it will never be a prime number since it's divisible by 3. So we can finally conclude that, okay, then it must be the case that p should be p should be congruent to 0 modulo 3, and the only solution here is p equals 3 because p is a prime number. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.